So we're going to take a look at something called the remainder theorem, and also we're going to look at the factor theorem. This is all in one show. Remember synthetic division? We just finished synthetic division, and we're going to use this to find our factors and to look at remainders. So the remainder theorem says if you have a polynomial and you divide it by x minus h, the remainder is r is equal to the function that you take your h value, you plug it in, and you can find your remainder. Let's take a look at this long division, okay? So x minus 3 is our what? That's right, it is our divisor. And then the minus 5 is what? That's right, it's our remainder. Now notice here that if I had just taken the 3 from the x minus 3, remember I'm going to use the opposite, the x is equal to 3, and plugged it in into the function x squared minus 2x minus h, then I would wind up with the same remainder. So the neat thing is if they ask you for the remainder, all you have to do is take whatever value they want and plug it into the function where x is, and you will get the remainder. So that means you don't have to do the long division or synthetic division. So let's take a look at this. This is a remainder theorem problem that you will probably see on a test. It says that x cubed plus k x squared minus 4x plus 2 is divided by x plus 2, and they give us the remainder is 26. And then they'll tell you find k. Well, we can set our entire function equal to our remainder. There's our remainder. Remember, is means equal. And then we need to remember that x plus 2 means that x is equal to negative 2, the opposite. And so we're going to substitute the negative 2 in for all x's. Notice that. So we put it in there, and then we're just going to solve for k, which means that this turns into a multi-step problem. So I'm going to wind up with 4k plus 2 equals 26 because my 8's canceled. I will then subtract the 2 from each side, and I'll get 4k is equal to 24. I divide by 4, and my k is going to be equal to, that's right, k is going to be equal to 6. All right, so that's one way. That's the remainder theorem. Now we're going to look at the factor theorem. And the factor theorem is when, instead of having a remainder, we have no remainder. It turns up 0, okay? So we're going to show that x minus 2 and x plus 3 are factors of this quartic. F of x is equal to 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. So remember, you just have to to do the synthetic division, you're just going to take all your coefficients and write them down, okay? We're going to look at the first x minus 2. So what number are we going to divide by? That's right, we're going to divide by a positive 2. So remember, it's always the opposite of what's in the parentheses. We're going to drop our 2, and remember, we're always going to multiply by our positive 2 and then place the number to the diagonal. 7 plus 4 is 11. So I'm going to take 2 times 11. It's going to give me 22. Negative 4 plus 22 is going to give me 18. Remember that 2 times 18 is going to be 36. 27. Negative 27 plus 36 is going to give me a 9. And then 2 times 9 is going to give me 18. And negative 18 plus 18 is 0. And so as soon as we see that our remainder is 0, then we know that 2 is a factor, a x-intercept, a root, a 0 of this function. Okay, so look at that. All right, these numbers that are left, the 2, the 11, the 18, and the 9, we're going to look at our next set of parentheses, x plus 3, and what number are we going to divide by next? That's right, we're going to divide by the negative 3. So again, we're going to drop the 2 down, and it's going to be negative 3 times the 2, and then we put the number up, negative 6, so 11 plus a negative 6 is 5. Then it's going to be 5 times negative 3 for negative 15. 18 minus 15 gives me 3. Negative 3 times 3 gives me a negative 9. And again, I wind up with a remainder of 0. So I know that negative 3 is also a factor. Okay? Now we are left with a 2, a 5, and a 3. And so remember, this started with x to the fourth. This down here would have been x to the third. And so this is going to wind up being x squared and an x, and then the constant 3. Okay, so we're going to take a little closer. So in the first two lines we saw from the last slide, but now we must factor the 2x squared plus 5x plus 3. Notice we have a number, a leading coefficient in front of the x squared, okay? And to factor this, we must use what's called MA, which is multiplying and addition. Okay, so we're going to multiply 2 and 3 and get 6. That's going to be equal to 6. So what numbers multiply to make 6 but add to make 5? Well, that's 2 and 3. Okay, so we're going to rewrite our equation as 2x squared plus the 2x plus 3x plus 3. And now we're going to use the grouping that we learned. Notice that when we do the grouping, what is our GCF coming out of each parentheses? So what numbers are we going to be able to take out for our GCF? That's right, we're going to be able to take out a 2x, and we're going to be able to take out a 3. And so those will go into a set of parentheses for 2x plus 3, and then we have the x plus 1 in the other parentheses, which also tells you if it's x plus 1, then we know that x is equal to negative 1 as one of our factors. And then the 2x plus 3 means that x is going to be equal to a negative 3 halves for the other factor. So remember, factors are equal to 0, so we get to set these equal to 0 and then solve for x. And that gives us all our factors for that quartic function. Okay, so the use of the remainder in synthetic division. The remainder R obtained in synthetic division provides the following information. Sometimes it's equal to some value. You put in a number, you find out what your remainder is, and that's the remainder theorem. But if R is equal to 0, then that tells us that the x minus h is a factor of f of x. And if R is equal to 0, then h comma 0 is an x-intercept of the graph of f. Okay? And thank you for your participation. The end.